Hello, and welcome to part 2 of our video series. In this part, I'm going to be showing you this, how to do this kind of structure, and we will be kind of going through the motions of the first part as well. So make sure that you watched that before you jump into this, right? Those of you who are familiar with the channel will recognize the structure as something that that's already been done on the channel, and also that's already been imported into Unreal Engine like a year ago or something like that. I had a tutorial series for that. And the main difference between the videos there and the video that I'm recording right now is that back then we would import this whole structure as a single OBJ mesh file. So it would just be like a large mesh file with every element in the structure being a unique object, right? That was a very the main difference from what we have here. What we have here is 14 elements, a library of 14 elements. You can see them in the bottom. And those 14 elements are copied and rotated into place according to an Excel spreadsheet that I can actually show you. Where do we have it? Right here. Right? So a spreadsheet basically. What's the benefit of this? Well, the benefit is optimization, right? I can go in here to these elements and I can change any one of these. I can change their form, I can change their material, I can change their behavior in general. And my whole structure, all of the elements in my structure will update automatically. So you can think of it as we are creating blocks in Unreal Engine. This will be very, very useful in the third part or fourth part of this series, right? So it's going to be highly optimized for geometries or for structures that use a copied element, or in this case, a library of elements. I hope it makes sense. So if you're planning on doing something that's going to be repeated quite a bit in your script, then definitely check out this tutorial. Okay, let's jump into, let me close that, and let's jump into Rhino. So first things first, okay, let's close that. First things first is in Rhino, sorry, in the video description, you will see a download link for the Rhino file and also for the Grasshopper file. I think I'll just zip it, into one archive, but it's going to be the Rhino file and the Grasshopper file. I just don't want you to start from scratch, because this has already been done in the previous tutorials. But by the way, if you want to understand the logic of how this whole thing works, how the script works, then definitely check out my custom marching cubes algorithm tutorials. Custom marching cubes. There I explain everything about this, but for this particular purpose, we're just kind of using it. So just to guide you through the files, the Rhino file will have these boxes, these voxels, and it will have these elements in it. And for some reason, there's like two. And all of these elements were modeled by me, and they're just sub-D geometries, right? We don't really mind, we don't care about the sub-D geometries. What we care about are blocks. So if I type in block manager, I can see that there's element 1, element 10, for some reason, element 12, and so on. Like there's 14 different blocks that are named with different element names, right? And if I were to say, for instance, insert, and I were to choose element 5, right? And I hit OK, and I say that insertion point is world 000 and hit enter. Is it hidden? I think it's hidden. Feels like it's hidden. Whoops. Oh no. Oh no. No. Insert again. element 5. Okay, let's first hide the geometry so that they are not getting in the way. Jesus. Insert element 5. Okay. 0. Why do you not? Oh, that is my bad. It's very, very small. So actually it needs to be scaled up 1,000 times. But if I just scale it from this point 1,000 times, then it's gonna be the correct size. Oh, sorry, god damn it, 100 times, not 1,000. There we go. Now it's sticking properly. That's my bad. The blocks have been scaled previously, and I haven't unscaled them. Right, so they are kind of they still retain their original scale. Let's do this again. I'll just insert and I'll choose element 1 because I have fixed it, and I'll just hit OK and type in 0, hit enter, and now we can see that we have our little block here. All you need to know is that for each of these voxel types, we have an element block associated with the voxel types. And then basically the way this works is if we have these two, let's say these 2 points, right? And I reference in these 2 points right here. I hit the reset button right here for the loop. So it recalculates. And then I just click on this place block, this button right here. It just generates a little form for me, right? If I were to copy this, by the way, the grid of points needs to be every 1,000 units. The gaps needs to be 1,000 units. So you can only copy the starting points by 1,000, right? Either to the side or up, like that, right? So it's always 1,000 units. Set multiple, recalculate, always reset the simulation. Place block, yay, another kind of structure, right? So that's basically how it works, right? That's the idea of it. And again, if you want to learn more, just look at those tutorials that I've done about this custom marching cubes algorithm. So the problem is that how do we get this into our Unreal Engine scene file? I don't know, scene probably. Well, we need to write the translation of each of these 14 elements, right? Let's actually bake this out. So for instance, here, right here, we have element type 1, right? It's, there we go. It's this element right here. We have element type 1, but it has been rotated, right? And placed here. Then here we also have element type 1. It also has been rotated and placed here, right? So it has position and rotation. It doesn't have scale information though. So we need to write a script or add a script to our Grasshopper files that will enable us to save information of which element is used, right? So basically like either the name or the index number, something like that. Then we need X, Y, Z coordinates of each element. Where is it placed? And then we need rotation around X, rotation around Y axis, and rotation around Z axis. Once we have all of that, we can rebuild the structure in Unreal without actually needing to import, like with having both of these elements as one and just kind of making a copy of it automatically in Unreal Engine. So that's the plan. All right, let's do this. So I'm just gonna keep only these 2 points so that it's very neat and dandy. Set multiple. There we go. Reset. Okay. So it only calculated the structure for these 2 points. If I bake it out, it's gonna look like that. Great. Now we need to somehow break away from the information for our Excel spreadsheet. right? So the first thing that I'm going to do is Unreal Engine, to be able to read your Excel, it needs the first row to have just numbering, you know, from 0, and it just goes through every entry, right? So 0, 1, 2, 3, 4, 5, and so on, right? So just kind of an index for which line we're dealing with, right? So I'm just going to, here in the back of the script, I'm just going to write // and I'll just say index, enter. So I have my little index node or panel, and then I'll create series of numbers like that. I will say that we need to count according to how many elements we'll have here, right? So how many elements there are here. And the way we get that number is actually either through here, or through here. It doesn't matter which one we use. So I think I'll just say according to how many names of the elements we have, we're just going to count the names. So name, let's just say list length, like that. Connect name to list length. Oh, you need, let's do that. You're gonna like this, bifocals. So list length from the name connects to our count. That's how many times we count. So we count up to 12, right? And we're basically, the way we structure this, remember from the first tutorial, we use merge, right? We use merge. We connect these two bad boys with merge, like that. And we get, we get a very crappy, we get a very crappy data structure. So let's simplify, or sorry, let's flatten the D2 input right here to basically force everything into one big happy family. And if I were to show you the output, it would be first the name, index, and then it just starts counting, right? So imagine the Excel spreadsheet, index 0, 1, 2, 3, you know, it just keeps counting. Great. Then I'm going to separate them into separate, how do you call them? Branches, into separate data branches. So I'm just going to choose to graph. And also, just to be sure, I'm going to choose to simplify it. So it's right click on the merge output, simplify and graph. That's it. This part is, actually, let's do it this way. This part can be grouped and it's done. It's our first row, or first column, sorry, of the Excel spreadsheet, the index column. Then the second column, I think we can immediately jump to creating, we need to specify which element needs to be selected, right? So I'm going to say / element index, L-index. You can call it any way you want. Just remember what you're naming it, right? So in my case, it's element index. Same thing, merge from, oops, come on. No, go back. There we go. D1 and D2 will get flattened. And now we need to get the element indices. Remember the names here? Let me just show you it with a panel. So this is the output of all of the names that are used, all of the block names that are used. We can work with that because all of my blocks have been named element 1, 2, 3, 4, 5. I was very kind of accurate with the naming of them. So it's not like potato element or whatever. It's element 1, 2, 3. So we can use these numbers. These numbers can be used. And that's very important. So I'm going to just say, how do we do this? Okay, so this is text. That's important. So let's just create a text node like that. So I connect my name node to the text node. Perfect. So literally it's the same thing. And then let's separate out, because I don't need the first two, EL. I just need the number. So let's get rid of the first two letters. I think under sets, under text, there is characters. So we split it. We split each line of text into characters, EL1, EL1, EL2, and so on. And then we will cull index. So we will cull the first character, which is index 0, and the second character, which is index 1. So I'll just create a panel, // type in 0, enter, type in 1, and click outside. Don't press enter again. So you only want two lines, 0 and 1. Click outside, right click, and disable multi-line data here, like that. So you should see something like this, 0 and 1. Great, we connect that to I. And now if I were to check this, now it's only 1, 1, 2, 2, 1, 1, and then so on. So these are which elements are being used. A little problem. I, as a normal human being, like to count from 1, right? Like 1, 2, 3, 4, 5, and so on. When we're dealing with lists, both Unreal Engine and Grasshopper or Rhino likes to count from 0. So whatever element 1 is, its index actually needs to be 0. Whatever element 2 is, its index needs to be 1, and so on. So everything kind of shifts backwards by one number. So I'm just going to say, from these numbers, subtract 1, like that. So 1 becomes 0, 2 becomes 1, and so on, right? I will take this and I will connect it to merge. Here, we can minimize that. I'll connect it to merge, and again, this needs to be flattened. Don't forget, D2 of merge always is flattened. Always. In every single thing that we will do, D2 of merge is flattened, and the output is always going to be grafted and simplified. This goes for every single merge. 99% of your problems, I promise, are going to be because you forgot to do either one of these, right? Okay, so this is second part done. We know which element is chosen at which voxel, at which time. Okay, great, we're blasting through this. Now we need the location. Or we could do either location or we could do rotation. Did they get rotated or located first? I guess. Yeah, I guess let's do location, because they are kind of being pushed and then rotated. That makes sense. So for location, I will do. Actually, let's think. Do we have anything here? We have voxel position that we can use. Oh, that's very nice. So voxel position is basically, it shows us exactly where each element is, and that's X, Y, Z, and so on. Wonderful. So we can use that. That is a vector though, or a point, coordinates. So how do we separate it out? Okay. Let's deal with this like we are dealing with text, right? So I'm going to create text component, connect my voxel position to text. I'm just waiting for you to catch up. I hope you connected it. And now we drag the text up, like below our first two groups here. So the text that is connected to voxel position has been dragged here. Okay, now we kind of do the same thing, right? We just get characters, we separate out the characters, and we take a look at what we get here. Okay, so the first bracket and the last bracket need to go, right? That's the first thing that I need to get rid of. So I'm going to say, again, cull index, And this time I'm going to do dash dash. We call the first one. So we will be calling 0, but also we will be calling -1. So 0 and -1 get called. -1 means that it kind of wraps back into the start of the list or the end of the list, and it removes the last item. That's when you count backwards. Well, with index, that's what it does. So we connect that to index, and you can see it's red, right? And it says data conversion failed from text to integer. And this happens when you don't choose multi-line data for your 0 and -1, or for something that is written in multiple lines. If you have multi-line data enabled here, it's going to read it as a poem, so as text. It's not going to read it as series of numbers. So just make sure that its multi-line data is turned off. And now you have, we have essentially removed the brackets from the start and the end of the coordinates. Then I will use, probably you can just text join, why not? Text join. Let's see how it looks like. Okay. Okay. So we get that. Sorry, I'm just kind of thinking of what we should be doing. So now we just need to, since we got rid of the brackets, we need to separate these into 3 entities, right? So we just do text split. And our splitting guy is going to be the comma. So dash dash comma, like that. That's what we get. 1000, -1000, -1000, -1000. I think the spacebar here is not gonna be a problem. It shouldn't be a problem. Just to be sure, let's do a number node right here. And let's connect it that way. That kind of gets rid of the spacebar. Okay, great. So now we have XYZ coordinates, XYZ coordinates, XYZ coordinates. Well, from here on out, it's pretty straightforward. We use list item to get, and we connect the numbers to our list item, and we get the first item of the list, which is the X coordinate. Second item of the list, I'm zooming in and clicking the plus sign. The Y coordinate, and third item of the list, the Z coordinate. Okay, let's create the panels and create the merge. Actually, I kind of want to just copy this. So I'll copy element index and the merge like that. And I'll just rename it to x-location or x-lock. Copy this again. Y-lock. And let's copy this again. Z-lock. Okay. And basically our list item I goes into D2 of X plus 1 into D2 of Y plus 2 into D2 of Z. And let's just make it neat and tidy by removing D3s. It likes to automatically do that stuff. We don't care about it. And basically, we have successfully extracted X, Y, and Z locations of our elements. So we know where the elements are, and we know which elements there are according to the library that we will provide. Now we need to deal with the rotations. All right, this is the fun part. Rotations are going to be tricky. Well, actually, I can already kind of tell you that location is also going to be tricky, and the Y location is not true to what we actually are going to be doing. Whew. Okay, let me try to explain this. I hope you're familiar with the right-hand coordinate system and the left-hand coordinate system, right? So in this case, Rhino, or let's do this. Right-hand coordinate system. Kablamo, images. There we go, perfect. We will be using this to explain. These are two coordinate systems. Guess, just take a wild guess if Rhino and Unreal Engine are using the same one. They are not. Rhino uses right-hand side coordinate system, Unreal Engine uses left-hand side coordinate system. It makes a lot of problems for us because everything imports flipped and everything is messed up and so on. Thankfully, there are certain, like when you export an FBX or OBJ file, there is a certain meta information written in the file that tells the software which coordinate system was used so that it imports not flipped. But all of the rotations that we do in the right-hand side coordinate system, such as in Rhino and Grasshopper, will not translate directly into a left-hand side coordinate system. For instance, since y is flipped, and that's the only thing, by the way, between these two systems, y is flipped. Since y is flipped, our rotations along the y vector are going to be going in another way, counterclockwise, not clockwise, or clockwise and not counterclockwise. So all of the angles of rotation need to be flipped around the y axis. That's first thing. Second thing is everything that we move along the y axis needs to also be flipped and be moved in negative along the y axis. Second thing that needs to be translated. Third thing, and by the way, this took me like 3 years to 3 years. No, what? Not 3 years, 3 days. 3 days to research and to figure out. Third thing is the rotation around the z-axis needs to be flipped. That flipping the y-axis also flips the rotations around the z-axis. And last thing, everything that imports into Rhino, into Unreal from Rhino needs to be rotated 90 degrees around the x-axis. Okay. We will be getting back to these statements in a short while. So actually, let's go back to these statements. Y location. Remember when I said that y is flipped? Yep. So in here, it needs the y coordinate needs to be a negative of whatever we used. So we use a negative number, right, from what Rhino uses. And for now, that's the only thing that changes. Now let's go to the rotations and fix that. So to get rotations, we will be using the transform information. And the problem is that I have all of the transforms stacked like that as compound transformations with 4 transforms in total. Oh, because the last one is move. Yeah. So it rotates, and then moves. So I need to split them apart. I think it's under transform, utilities, split. Kablamo. When we split them, it creates a data tree with 4 transforms in each data branch. So this is for each element. We get 4 transforms. Rotate around x, rotate around minus y. Remember the minus y part? We will be using that to our advantage. And rotate around plus Z. And then move. We already have move information, we don't care. So we use rotate. We will just be using rotate information. Okay, so we have that, right? Let's separate all of these lines into their own little branch so that we can deal with them. Graft. Okay, now they're in their own little branches. And first of all, let's get rid of the rotate and let's get rid of the about and X, right? So we will just say text split. There we go. And we split the text with, oops, not a 0, with a spacebar. So, come on. There we go. This panel is not empty. This panel contains a single spacebar character. So I just put a spacebar and I clicked outside and now it has a spacebar in it. Once we do that and we connect it here, we have rotate 0 degrees, about plus X. We care about 0 degrees, right? We only care about that. So I'll use list item in this case. And I'll just say index 1. Just like that. Connect it. And now we just get our little degrees and our coordinates here. We don't care about the coordinates again. We care about the degrees. All right. Whew. So now when we have the degrees, we need to separate out the zeros, right? Or sorry, the numbers. And it's basically us just removing. Do we just remove the first and the last item and the one before the last? Okay, let's first separate out the characters. Separate out the characters. Kablamo. Col index, you know it by now. We've been using it for a while. Col index dash dash 0, 0 and -1. And expand this, multi-line data, expand this more, connect. And I believe we just use text join, right? No, sorry, we need to do -2 as well. Let's just see. Yeah, because we get the freaky little degree mark here that we need to get rid of. So -2 as well. Yay, the freaky little degree mark is gone. And now you just use text, join, connect everything like that. And we have our degrees, 1, 2, 3. Yay. Now, let us simplify the output so that our addresses, data tree addresses, don't look this way, but rather look clean and nice. And let's go back. Remember where we separated them out here into separate branches? Let's go back and merge the branches back into what they were. So 0, 180, 90, and the coordinates need to be in one big happy list. And then 0, 180, 180, and the coordinates need to be in their own separate happy list. So we need to go back one step. The tool that does that is called trim tree, like that. Connect it, plug it in, and it works. It just works. Okay, now let's separate out our rotations. So I'll use list item, and I'll just expand. Rotate around X, rotate around Y, rotate around Z, and the coordinates. We don't care about the coordinates, so I'll just minimize that. 0, 1, and 2. Those are the important ones. So, how do we deal with those? Honestly, I think, do we need to do anything with them? No, we don't. We just kind of yoink. Let's yoink the merge again from here together with the panel name. Z location and merge. I'll just disconnect it for now. Because we'll have like rotate rot-x. So that's going to be the first one. Then we'll have rotate-y. And we'll have rotate-z. Yay. And we just connect them. Do we? I think we kind of do, don't we? Yeah, let's just do it. Connect, connect, connect. And get rid of the D3. I don't... Sure. Now, the scary bit. Well, it's not going to be the scary bit. It's just this bit right here. Right hand side, left hand side. So we dealt with the position, right? So we're going backwards with the location. That's fine. But now let's talk about the rotations. X doesn't change. Well, X rotates 90 degrees, but we can bake it into the script on the Unreal Engine side. So we don't care about it right now, but we care about it rotating backwards around the Y and rotating backwards around the Z. Okay, so let's talk about the Z. Let's start with the Z. That's easy. Negative. Book. That's done. Right. Now let's talk about the Y. Remember, and this took me a while to figure out. Remember, as we split the compound transformations, it said that it's rotating around X, right? Around plus X, and not rotating around plus Z, but it's rotating around negative Y. While here, we're going to be describing that it's actually rotating around positive Y. So initially, if we don't specifically say here that it's negative, it's already going to be flipped from the original, right? So we're initially, by not adding negative here and not by rotating by negative Y, but rotating around the positive one, we're initially just translating it to from right hand side to left hand side coordinate system. So we don't need to do anything there. A lot of words for not needing to do anything, right? But I feel like it's important to kind of explain so that you at least have an idea of what the hell is going on. All right, what else is there? No, we have everything, right? So this is gonna be our rotations. Let's merge it all up. Merge. Goes to D1, D2, D3, and so on. Wunderbar. Okay, so all of these got merged. Now, according to regulation, all of these need to be joined up. Text join. Oh, before you do this, just check with the panel, or not even a panel. You can just hover your mouse over the R output and just check if the data tree looks something similar to what you're seeing right now on my screen, right? You don't have like weird addresses and so on. It's like 0, 1, 2, 3, with 8 elements in each list. If you have like weird addresses, double check your merge. Make sure that everything is flattened here, simplified and grafted here for every merge. Okay, text join, and we join all of the text with a comma. So panel, comma, connect. Easy. Easy, easy, easy. Then create a new panel, connect it there. Do we flatten it? I think we flatten it. Right click, flatten the text join output. And this is going to be your Excel spreadsheet. So you right click, choose your stream destination. We can go for there, and I will actually create a new folder and say my Excel. That's not how you write Excel. Excel lives here. Perfect. And change the data type to CSV and name this MC, like marching cubes, or CMC, I should say, CMC to UE Excel. There we go. Hit save, then right click and choose to stream the contents. Okay, great. We have, let's double check. Bam, bam, bam. This is where it is. We have ourselves an Excel spreadsheet. If I open it up, we have index, element index. So index is just, forget about this. This is just counting. Element index, which says which element we're using. X location, Y location, Z location, rotation, rotation, rotation. All we need. Great. Grasshopper, then grasshopper part is done. If you were very lazy, you can still get all of this if you're a Patreon supporter of the channel. You'll get like literally everything that I do for the channel. Right. Selling out really kind of messes with my attention very hard. Continuing on, we have now the information from what's being moved, but now we need to create an element library, right? That is going to be moved. And as I said, we have, you know, like insert, and we can insert like different elements, element 14, for instance. I think we need to scale it though, 1,000. No, not 1,000, sorry, 100. My these elements have been kind of messed up a bit. 0. Sorry, just a second. No, this one is fine. God damn it. Insert without scaling. Insert X, just 1. Enter. Yeah, add 0. Right, so I have all of these elements, but the problem is that they're located here. No. The location of them before the export needs to be that they're centered around the... They're centered around the voxel, or rather the voxel is centered around the world XY plane. That is why I have, let me just open it up, this element library right here. And the element library, you either make it yourselves, right? So you can just export the blocks and make sure to explode them. So you export and you explode them into meshes, and then you get them in here. And basically each of the voxel that is used needs to be centered around 0, 0, 0 point, and then you place the elements inside of it before exporting, right? I really hope that this makes sense. If it doesn't, I don't know how to explain it better. Okay, so the reason for this is because all of the rotations of the elements are going to be done around their center point, and their center point needs to be this point that is 0, 0, 0 in the world, right? So for instance, element type 1, if I say that it needs to be rotated around Z by 90 degrees, it's not going to be rotated around its own like center of mass somewhere here. No. It's going to be rotated around the center point of the world. right, like that, and you can see that it still fits really, really well with the voxel. That's very important, so keep that in mind. Patreons get this file as well, just so you know. So we don't save the changes, but basically from here on out, all of our files that or all of our modeling and changing of the geometries and applying textures and whatnot are going to be handled with the element library file, within the element library file. So keep that in mind. The way I export them is I just select the mesh, export, type in export, create a folder named MC elements, and the options that I use are, where is it, OBJ format. And if I were to show you the options, it's polygon mesh objects, formatting, Windows, export material definition. Sure, it doesn't really matter. Map Rhino+Gh to OBJ-Y, that's important. And then from here on out, it's honestly, everything else is default. Yep, everything else is default. One last thing that I do with these meshes, actually before I export, is I change their name. So for each mesh under properties, I change their name to the corresponding like name that I want to use, element1. And I also export them as, where is the OBJ? As 01, 02, you know, so everything is, all of the information that I write corresponds to which element I'm dealing with. If you start saying like my first element, my second element, and so on, you're gonna have a very hard time later down the line. So just be very simple and very strict with how you name things. All right, so that is kind of the initial idea. Then we actually, let's do a break, and then we will move into Unreal Engine and get the party going. All right, let's go for this. So this is my file that I used in the first tutorial or first part of this series, and we're just going to continue building on it. So if you have it, open it up. Okay, and in that file we have our YouTube map. This is actually the map in which we're going to kind of continue working, and I'm just going to take a look at what we have here. If I press play, it's a heavy one, isn't it? Seems like it's gonna be a heavy one. Oh yeah. So this is what we had last time. Quite nice, quite pretty. And the frame rate is also okay. It's like with me recording it and with Rhino running and so on, it's still hitting like 30 frames per second, which is, you know, playable. All right, so that's our little map. So now to actually kind of start replacing things, I'll just open up my stuff here, and I'm going to probably just delete everything, right? Makes sense. I'll just delete all of this. Delete, force delete, and it's all gone now. If I press play, now it's gonna be empty. Okay, now let's create a new folder in here in the content browser under my stuff. I'll just create a new folder and call it elements. Elements. Open up that folder, and I'll just get all of my elements into it. So everything that I have exported, that I showed you how to export one by one. Where are they? There we go. So all of these elements, I'm gonna drag those in. So Oh, by the way, I have this XYZ test object here that I can also show you. This is just let's just import it. This is just for me to show you how stuff imports, and actually I encourage you to try it out yourselves, creating something like this to understand, you know, how stuff is oriented after you import it, right? So you can see that the Z is looking towards negative Y, and Y is looking towards negative Z, and X is normal. So honestly, if we just rotate everything by 90 degrees, now Y is flipped, yes, but that's fine. That's fine with us. X is looking in the correct direction, and Z is looking in the correct direction, right? So we're basically importing it as it is, as what we saw in Rhino. So this kind of little 3D model, I used it a lot, and it seems to be quite useful. After I'm done with it, I'm just gonna delete it, gonna get rid of it. There's also grasshopper box right here. I have no idea what that is, so I'm just gonna casually delete that as well. All right, so importing stuff. I'll just select the 3D objects right here from the first one to the 14th one, and drag them in to my elements folder right here. As I'm doing that, it's going to give me FBX import options. And here the important thing is to build nanite. So I have that one ticked. And then for transform, I will choose import rotation here, import rotation X to be 90 degrees, right? So it imports rotated 90 degrees around X axis. So everything is accurate. Convert scene, force front X axis, convert scene unit. Nothing else needs to be tick marked. Import all. And then we wait a bit. It's gonna say that no smuggling group information was found. We don't care. We clear that. Close that. All right. So now let's just wait for it to stop freaking out with the shaders. There we go. We have our material that is kind of slapped onto all of these elements. I can actually wait. Do you see the material? Or is my face in the way? Where is the camera preview? Yeah, you can kind of see the material. So I'm gonna double click on it, expand this, and I'm just going to make the material a little bit less bright. So I'm gonna choose the param, and where it says default value here, I'm just going to choose a slightly darker color like that. Okay, seems to be, well, you can go for a darker. Yeah, something like that. Nothing more. You could start messing around with the metallics and so on, but not in this tutorial. In the future ones we will. I'll just hit save. All of the elements will update. Hit close. We're good. We're Gucci. Okay, so we have all of our elements here set up, and I can place them and move them up. And if I press play, play in editor, I can see, you know, I can investigate how the element looks like, what's the scale, and so on. And it even has what's the word that I'm looking for? It has collision attached to it as well. Let's move it down a bit. And you can also see that the 0, 0, 0 of the element is not in its center point. It's actually where we had the 0, 0, 0 coordinate of the world in our Rhino file. So let's press play again, play in editor. Come on. And you can see that, oh, it's actually using a bounding box for the element, for the collisions of the element. Not a bounding box, sorry, it's using a simple collision. So it's like a convex hull shape around the element. We are going to fix that in a second, but not right now. Okay, so we got that working. Now let's go back to my stuff folder and let's actually import the Excel spreadsheet. Right? So remember in our first video, we couldn't just import it just as it is. We needed to first go to blueprints and create a structure for basically Unreal Engine to know what's the information that it should expect from the Excel spreadsheet. So structure is very important, and I'm going to say CMC to Unreal Engine struct. Something like that, CMC to UE struct. Again, right click, blueprints, structure. That's how you get it. And I double click it, and here I will just create the structure, right? So what are we expecting to see? We're expecting to see, let's open up like right here. We're expecting to see element index. We skip over the first index, by the way. We don't care about this, right? So we only care about the numbers right here. So the first entry is going to be element index, L-index. Let's open up our struct, and we just write L-index. And what kind of type is it going to be? Well, it's going to be an integer. Full number, right? 0, 1, 2, it won't have anything after the comma. Then I'm going to add a variable, and I'm going to call this, we need to check, x-location. Okay. x-loc, and it's going to be a float, so it can have a comma. It won't in our case, but it can. I'll add a variable again, y-loc, also float, and add variable z-loc. Okay, and last one, just to be 100% certain, you need this to match up, by the way. Last one is rot-x-y-z. Okay. Add variable rot-x, add variable rot-y, add variable rot-z. Great, we have it all working. So all of these are also going to be float numbers. That's done. We save it and we close it. We have our structure. Now to import the Excel spreadsheet, we literally just take the file and drag and drop it in. It's going to give us data table options where I need to choose. We're going to import it as a data table, but what kind of type it is, we need to expand this and choose CMC to UE struct. That's the one that we're going to be using. Click, apply. That's it. We have ourselves our Excel spreadsheet in Unreal Engine, just like we did in part 1. So if you didn't follow part 1, here you go. Now to actually make use of it, well, first of all, we need to read it in our level blueprint, right? So I'm going to create I'm going to open the level blueprint, so we can do this through here and through here, open level blueprint. And I'm just going to honestly dock it So I'm taking it by the name, and I'm just gonna dock it right here so that I can switch between the level and its blueprint, like so. Very convenient. So once I have that done, you can see that I already have stuff happening here, and that is, of course, from our first tutorial. So I'm going to kind of continue building up from there, from here. And by building up, I mean not much will change. So after we begin play, we need to get the row names, right? From what table? Well, we have a new table, so I'm just gonna select the asset and choose CMC to UE table. There we go. Then we go through the names and we extract the data. So data table, again we choose CMC to UE, and it gives us an error. We'll see. We'll see if it's still gonna give us an error after we're done. So it's gonna break, but we need to break out the information, right? But now it's breaking out the old information. So I'm just gonna delete that. And actually I'm gonna delete the spawn actor as well, just because it doesn't exist yet. So first of all, let's break the information into separate outputs. From the out row, I'll just drag it out and I'll choose to type in break. And the only option that I have is break CMC to UE struct. Like that. Expand this. We have ourselves, you know, the index, location, 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 rotation, rotation, rotation. I'll compile this. I'll save this. Now this is not complaining anymore. We have the numbers. Great. That's it. We don't need to do anything more with the map. We will, however, we'll be returning to this, but not right now. Back in our environment, or in our actual map, not the blueprint, I'm going to create an element blueprint. And that blueprint is going to be the one that's going to be driving, what's the name? It's going to be driving the copying and the rotating and so on of our element. And we've been doing this in the first tutorial as well. So if you don't know what I mean, pay attention. Okay, so under blueprints, or rather just here, right clicking and choosing blueprint class and choosing actor will do the trick. So we're creating a blueprint actor, and I'm just going to say element dash BP, element dash blueprint. Double click on it to open it up, and here we have the scene, right? So again, viewport, construction script, event graph, right? So we care about the viewport and we care about the event graph. We don't care about the construction script. In the viewport, let's first work with this. Let's first make this whole thing work. So I'm going to drag out, here you can see I have like 3 tabs now. My map blueprint, and my element blueprint. I'm going to actually drag out my element blueprint like that, make it a bit bigger, like that, and turn on my map. And in my map, under content browser, I'm gonna go to the elements tab so that I have my ready-made elements here. Let me experiment let's try one thing. I wonder if this is gonna work. This kind of works. All right, I can do that. I think. I'm scared to do a new thing in. I'm scared to do a new thing in a tutorial, but hey, seems to be working. So why not? So you could just, let me delete that and do it again, by the way. You could just select the default scene root, click on add, and then choose static mesh. And you can choose static mesh 0, 1, for instance, and you know, wait. Oh, that's because I have this selected, isn't it? Let's try again without having this selected. Add static mesh. Yeah, there we go. Static mesh. and then call it L1 or element1 or 01, whatever you want to call it, and just choose which static mesh you're going to be using. But it seems like it's much faster to just take 01 and just drag it onto default scene root like that. So that's what we're going to be doing. 02, 03, 04, 05, one by one. I'm scared to drag all of them in all at the same time. I shouldn't be probably, but I am. So I'm gonna do it one by one. 12, 13, and 14. There we go. Once you have dragged all of these in, then you can take the element blueprint by the name tab and just drag it back to and dock it here. So we have the map blueprint, element blueprint tab. So this viewport is messed up, right? It shows us all of the elements all at the same time. That's normal. That's what I would expect to see. It's just because we're going to be using all of them all at the same time. If I compile and save it, it's not going to complain because it's literally all of the elements. I can also use in the map under my stuff, if I now drag and drop in my element blueprint, you can see the beauty that it is, you know, all of the elements stacked into one big happy family. I'll get rid of that though for a bit. Okay, so now coming back to my element blueprint to event graph, let's build it up. So one thing that's going to be different from what we've done in the first tutorial is that we need to choose which element is going to be copied. In the first tutorial, we just used a single element and we just copied it, right? Here we have 14 of them, so we need to copy those 14 elements. I guess let's start by just dragging them in. So 01, by the way, I'm on element blueprint, event graph, right here. And then on the left hand side, I have under variables, under components, right here, I have all of my elements listed here, right? So I'm just going to be dragging them in. Let's see if I can select all of them at once. No, I can't. That's great. That's wonderful. Can I select them here and drag them in here like that? I can. I'm not sure if this is gonna work though. Let's just see. 01 get. That seems like it looks the same way, doesn't it? Yeah, sure. Let's experiment. So just select all of these here in the top and just drag them in to the event graph. And then just make sure that 01, then 02 is after 01, 02, 03, 04. So count, basically. Count, and everything needs to be in order or else you're not gonna have a fun time. 08, 09, thank God for viewport snapping, huh? 11, 12, 13, and 14. Great. Now let's merge all of them into one list. How do you do that in Unreal Engine? Well, you make an array. Make array. Like that. Make array tool. Connect 01 to 0, and well, basically we're just gonna add a bunch of pins. So you just keep clicking on add pin until you will have from 0 to 13 pins, and then start connecting the wires. So we're basically just merging all of them into one big list. For those of you who know Unreal Engine better than I do, let me know if there is a faster way to do this part, because this seems to be, there should be like a faster way, but this works, so we're kind of sticking to it. Then from the array, we need to extract, like from this library or list of elements, we need to extract the correct one, right? So we're going to drag out from the array output, drag out and type in get. get in brackets a copy, like that, a big boy, right? And this is basically waiting for an index of what we're gonna be getting. So for the index, I need to create a variable, right? So I'm just going to here on the left hand side, I'll just click the plus near the variables, like that, and I'll just choose to create a variable called item or item index. There we go. And under, it's not going to be a boolean, it's going to be an integer, a full number, right? Item index. Let's minimize the components like that. So under item index, there's a few things that we need to change. First of all, we need to make it viewable or accessible by every other blueprint that we have, so that we can write what the item index is through the maps blueprint, through this blueprint right here, right? Because element index here and item index here needs to be the same thing. So I'm going to open up the I here. I'll repeat it. I'll open up the I right here where my mouse is. Okay. And then one or two more things that I need to change is expose on spawn. That's important. And I think that's it, isn't it? It's not private. Yeah, it seems like it's that. Okay. So after we've done this, I'll just yoink the item index in here, and I'll just say get, not set, but get item index. Plop it in there. Okay, so now the first row will select, the first row of my Excel spreadsheet will select which item from here needs to be chosen, right? And these items correspond directly to the geometries that we hooked up to this blueprint. Then after I've gotten the item, I will set the relative location, and I'll set the global rotation, not relative but global rotation. Okay, so to set the relative location, well, actually it's going to be done after the event begin play starts. So once playing starts, that's going to be done like that. And we choose to set relative location. What the hell is that? Oh, okay, so this is for each individual object, right? Element 01, element 02, and element 03. We can choose whichever we want. It doesn't matter. So let's just choose the first one. Set relative location. Bam. Then where it says 01, we just delete that. And instead, we choose that we are going to be setting the location of whatever we get, right? Whatever comes out from here, like that. Okay, that should work. Then for the location, we will create a vector because it's XYZ, right? So make vector, that's easy. The last one, by the way, make vector right here. And then for X, for Y, and Z, we need 3 variables. So I'm going to be just taking the item index here, and I'll be duplicating it. That's on the left hand side, right? I right click on it and I choose duplicate. And here I'm gonna say x-lock, and I'll change this to float because it's a float number, right? It's not an integer. I will duplicate it again, y-lock. That is a T. I can't write properly. Come on, let me change this y-lock and duplicate it again, z-lock. And honestly, as we're here, might as well duplicate it again, x dash rot again, y dash rot, and duplicate it again, z dash rot. The reason why I'm duplicating and not just inserting variables is because I would need to expose on spawn to tick mark this for every one of them, and also make them the eye open, make them public for all of them, and I sometimes forget, and this just makes sure that all of the settings carry over. Okay, so now we have X location. I'll just drag it in and choose to get X location. Then Y location, drag it in, get Y location. Z location, drag it in, get Z location. Kablamo. Connect, connect, connect. Okay, so now we have variables for item index and for X, Y, and Z location. Then after it's located, it's gonna be rotated, right? Rotate. That is casting set world rotation. There we go, set world rotation. So it needs to be world, not local or not relative. The reason for that is when I had to deal with relative rotation, it would constantly over rotate certain axes, and I had no idea why it does that, and world rotation seems to fix it, and I will not ask questions if something just starts working after 3 days. So it's world rotation that we're after. Okay, after getting and rotating, we also connect the gotten output here. After get, we connect that to our target of set world rotation. And then for the rotation input, the actual XYZ values, it's not a vector for some reason, it's a rotator. Rotator, and it's going to be right in the bottom of the list, make rotator. And it basically asks you for the roll, the pitch, and the yaw. So X rot get, Y rot get, Z rot get. X connects, Y connects, Z connects, and we're Gucci. So we're back to having like a similar script to what we had in our first tutorial, except for this whole part that is completely new. Okay, for now, let's just compile and save the element blueprint. Then let's go to our map blueprint. And here, let's actually write into those variables, so into these variables, X, Y, Z, and item index. We need to fill them in with numbers, and we will do that in here. So I will be using whatever it's called, like the spawn. I'll be using a command that's called spawn actor element. Yeah. So if row is found like that, we will spawn actor from class. Spawn actor from class, like that. And our class is gonna be the element BP, element blueprint, the one that we just literally created, element BP. And it asks us for a bunch of different stuff. So first thing that it asks us of is spawn transform. We can hook this up here, easy. That's done. And then because we already have the make transform, this is us moving it from 0, 0, 0 coordinates anywhere we want it to be. And also we can rotate it and scale it if we want to. Then we just connect our element index to item index, X location, Y location. We just kind of feed in whatever we read from the Excel spreadsheet into these values. And honestly, I think that's it. Compile, save. I'm missing something. Oh yeah, I'm missing the fact that now if I press play, the character and the structure are going to be spawned in the same place. So I think it's gonna crash. Let's try. Let's just see. Let me save this first. Control S and just press play. Yep, that is very, very dark. I think I'm inside of an element. Okay, so we need to spawn, we either need to spawn the character away from the structure or the structure away from the character. In our case, the character is spawned, since we don't, wait, we have player start, and player start is at 0, 0, 0. Well, almost 0, 0, 0. So the structure needs to spawn, let's say, it's looking that way. So let's make the structure spawn in X direction further out by let's say location in X direction. I'm in the map blueprint, 3000. So 30 meters forward. Compile, save, back to the map, play. There we go. There it is. Right? So that's our structure. It's all messed up. Why? Well, the messing up part is because the element blueprint, this guy right here, it also spawns itself. This one also gets spawned. It's not just what it reads from the Excel spreadsheet, but every element needs to spawn once, right? I still haven't figured out how to fix this, but or how to cleanly how to fix this cleanly. So instead I'm going to do what I do best and just fix it kinda. So in the event graph, wherever it says X location, or rather where it says Z location, I should say, let's just let's just add or subtract from the Z location a number, right? So that all of the objects that are going to be placed will be placed above, like higher up. So Z location, I'll drag out from here and I'll just type in the plus sign where we have operations add. And here I'll just write, just add like whatever, like 50 meters, 5,000 units. 5,000 units is 5,000 centimeters, which is 50 meters. And we will use the moved version here. Now if I compile, save, go to my map and press play, you can see that the actual structure is 50 meters above the ground, right? The Excel, the structure that we get from the Excel spreadsheet, while the element, like the blueprint, is right here, right? So the next thing that I'm gonna do is I'm just gonna sink it down back by 50 meters, right? So here we're using 50 to move all of the elements that we get from the Excel up, and I will just move the whole structure, the whole blueprint down by negative 5,000, which should, if I compile and save and press play, which should yeah create the elements that are kinda in the correct position. They're sinking into the ground because the ground, well, actually it's not raised that much. I wonder why they're sinking the ground, but you can easily control this by just moving this up by, let's say, 4,000 4,000 up. Compile, save, play. There we go. There's our structure, and we managed to figure it out. I can't step into the structure because, again, it's using the whatchamacallit, not the not complex geometry, but the simple geometry, the simple collision. but it's going to be an easy fix to work with that, because now I only need to fix 14 elements and not whatever elements I'm going to have in the future. Speaking of which, let's make it heavy. let's heavy it up, because it works, right? So I'm just going to make copies of my points to make a more impressive structure. Something stupid like that. So these points, let's grow it. That's not too many. Let's just check how many we can get later. But for now, it seems like it's 38 voxels. That's the Excel spreadsheet that we get, right? Why is the last one 0? Oh no, what did we do? What did we do? Just a second. Let's see where we messed it up. Because for some reason the last output is just 0. 40, huh? That's 39, that's 40. Okay, so element index is 40. But here it says 39 names. That is very funky. Let's investigate further. Okay, that's 38. Then we have proper characters. We have, again, 38. Oh, wait, there's like 2 numbers here. Why are there 2 numbers here? Is that because it's element 11? That's element 11, isn't it? Text, characters, we call index, and wherever we have element 11, it creates 2 numbers. Oh yeah, there we go. That's a bug that we need to fix. So the way we fix it is, wherever it has 2 numbers, it needs to also use text join. Text join, we just join up the text like that, connect it there, and now it's gonna be all neat and dandy, right? So 1 and 1 becomes 11. And now it's not 40 again, now everything is clean. Whew, that got me scared there for a second. Okay, let's look how the structure, basically this is the structure and how it's gonna look like in Unreal, how it should look like in Unreal. A few holes here. Ew, why is there a hole there? We'll figure it out later. So in Unreal, if I go to my stuff, if I choose to refresh or re-import my Excel spreadsheet and press play, there it is. There is the structure. And you can see that the frame rate is actually really good. My frame, oh no, I'm falling down. The frame rate is still 120 frames per second. So let's investigate how much we can push this. Oh, I always love these parts. Okay, let's take these and let's make a mirror of them. Well, actually a mirror of them. You can only move them to the in the positive X and Y, never go in the negative. That's not gonna work. Okay, we do that. Then let's mirror it again. Why not? Something like this. Like that. Sell duplicates, delete the duplicates. Let's just grab these and copy them up by 3000. Actually, Yeah, something like that. And then maybe this whole shebang gets copied by 2000, like that, then by 2000 more. Always keep deleting the duplicates as well. Okay, this should be a pretty, like a little bit more intense in terms of the complexity of the structure. Okay, 159 voxels. That's not too many, but considering that each of the elements has like 8,000, 9,000 polygons, you know, it adds up. This is how it should look like. I really need to fix the element type 5. I'll do that for the next tutorial. It still works, it's just not fixed in this Rhino file. Like that. Re-import the Excel spreadsheet. Press play. Oh, now that's lagging. I think it's loading in, honestly. Yeah, it's loading in the chunks. So it's gonna get better after it's done loading. But yeah, that's our little structure right there. Oh, and I fall down as per usual. Okay, let's stop calculating. And we can expand this. So let's make this a bit bigger. 16 by 16 by 16. There we go. Slightly bigger. Just so that I can move. Now I'm gonna move away from it. Oh my god, it's... And also this tells me that it's not the graphics card that's lagging, it's actually something else, because right now I'm not showing anything in the graphics card and it's still at 17 frames. In my experience, by the way, working with these structures in Unreal, for a while it does drop to very low frame rates, but then after like 20 seconds or 30 seconds of just kind of working, it jumps back to 120 frames per second and it's smooth like butter. I have no idea why that is. Okay, we are done. We're done with our initial structure. I will fix the collisions so that we can climb onto the we can climb on top of the structure and kind of get inside of it. So I will just select all of our elements, right click on them and choose to well, first let's enable nanite for them, but second, it's under asset actions. It's gonna be under bulk edit via property matrix, like that. So that's the property matrix that we're dealing with. And here I'm going to type in collision. And we need to find complex collision mesh. No. Where is it? Where was it? Wait, it's under static mesh, isn't it? Collision core and physics. Simple collision physical material, no. Collision complexity, there we go. Collision complexity. Instead of project default, we use complex collision as simple. Like that. We Ctrl S to save. Did we save? I'm not sure. Seems like we did. Why is there still a small little... whatever, close. Should be saved. I can actually open up one of them like that, and I can go to collision. Yeah, and here it says use complex collision as simple. That's great. That means it actually got fixed. So now if I press play, I get loaded in. It lags like crazy. Great. But now you can see that the collision is much more like natural, much more accurate. So let's see. Now I'm too big. I can't get in. I can't get into these structures. But let's see if we can spawn on top of one of these structures and get in that way. So I'm going to take my player start, wherever it is. Hello, player start. Oh, there it is, player start. And I'm gonna move it to X3000 and Z, I don't even know. So let's first move it to location X3000, like that. And then in terms of Z, probably somewhere here. Let's press play. Let's see. Oh, I was inside of an element. Press play again. Okay. So we need to step inside. I fell in. I think I will be able to... No, I can't. No, please. Please, no, I'm stuck. Okay, fine. Let's move it up a little bit more. Like that. And move it in X just a tiny bit more so that it's maybe spawning... Ah, come on top of the structure. I will show you later how you can make a flying character so that you can actually fly on top of the structure, but not right now. Okay, something like that. Yeah, there we go. Oh, that's actually naughty. I need to also figure out the walkable slope of these things. Right, how to make the character walk on a certain slope. Because right now the slope seems to be very punishing. No! Okay, I give up. That's gonna be it. That's gonna be that. So right now we're at 17 frames per second. I think if I under settings, under scalability settings, if we change this to medium rather than epic, we should get a little bit better frame rates. No, it's still those same 17 frames per second. So I think there's something wrong with Unreal Engine in general and the optimization of it. We'll see if there's any further optimizations that we can do, but as I said before, it tends to solve itself after a while. That is that, honestly. We are done with what we wanted to do for this particular second epic play. We are done what we wanted to do for this particular example. I'm pretty happy with it. And next up, we're going to kind of split this tutorial series into two parts, or not two parts, or two directions. One direction is going to be what we do in Grasshopper and how we work in Grasshopper with the elements, and how do we place the elements in a smart way. Because right now you saw me just copying the points, which was you know, not the smartest. So we'll make the structure interact with the light and then work with the light and so on. It's going to be nice. And the second part is going to be optimizing this, making the frame rate go up, making this nice, working with the materials, with the textures, making this as realistic as possible, right? So that's the two things that we're gonna be doing. Okay, all files are available for the Patreon supporters. I'll see you in the next one. Later.